I work at the Department of Geoscience at the University of Wisconsin-Madison. And I'm here to talk to you today about the decisions that I made and the lessons that I've learned throughout the past couple of years in implementing a data service for the project that I've been working on called the Paleobiology Database, which I will demonstrate briefly to you towards the end of the day, towards the end of the talk. Before we start talking about data services, it's best, I think, to set the scene and make sure we all are on the same page about what we're talking about. So, basic scenario, we have a server with a data store. Exactly what it is doesn't really matter all that much. You have some data that you want to provide access to clients somewhere else on the net. Straightforward. The idea is that you want the clients to be able to send a request and get some data back. Of course, this is a problem as old as networked computing, and many different solutions have been proposed for it. The current consensus is that under many situations, the best paradigm to take is an approach called REST, R-E-S-T. How many of you are familiar with the term REST? Okay, most of you. All right. So REST is a set of architectural principles originally developed for the web as a whole by Roy Fielding, who was one of the architects of the web. He worked with Tim Berners-Lee to develop HTTP back in the 90s. The term stands for representational state transfer. That's what he called it. But here's the thing you need to really understand about REST. There's no consensus about what actually this term means in practice. If you ask 10 different developers of a RESTful web service what REST means, you will get 10 different answers. Here are the original principles, basically, as laid out by Roy Fielding. Don't worry about memorizing this list because as you'll see in a second, that's not really the key thing that you need to understand. The original principles are separation of client and server by uniform interface. So far, so good. Intermediate servers can be interposed between the client and the server without either of them necessarily knowing that the intermediates are there. So caching and proxying are allowed in the model. Here's a big one. All client-server interactions are stateless. What that means is that the server should be considering each request from the client as a standalone operation, not in context of whatever the client has asked before or will ask in the future. Data is composed of resources, each identified by a URI. For resource, think object. So a data is an object that has an identifier, but here's the key, that identifier should be a URI so that you can send that URI to somewhere else or post it on a web page and identify a resource. Application, its state transitions should depend upon information embedded in the representations. That's often referred to as hypertext as the engine of application state. A very awkward acronym. I wish that Roy Fielding had thought of another one for it. But anyway. So that's the actual set of principles. Reality is probably not a single service out there that is labeled RESTful actually meets all of these principles. If there are one or two, perhaps, but almost there are thousands and thousands of things out there that are claimed to be RESTful services, and none, maybe a few, actually fulfill these. In practice, here's what REST tends to mean. You have one protocol layer, generally HTTP, and you don't stack other layers on top of it. So if somebody says, oh, I have a RESTful service, that's probably what it means. The basic interaction is the service gets an HTTP request message and it sends an HTTP response message. The meat of the request is the URL that's being sent and the HTTP method, get, post, delete, etc. And you don't package up a whole bunch of other stuff and layer something else on top. The headers and the status codes typically are used as design. So if you want to add extra information that you send to the server or the server sends back, you stick it in an HTTP header or use the HTTP response code. So then, in practice, yes, generally resources are identified by URIs. Again, this is important for the web because if you have, if your resource identifiers are URIs, that means you can put them on a web page somewhere. Some of these URIs might identify individual resources, or they might identify a class of resources that match criteria encoded in the URI. And then the third principle, important, is that client-server interactions are stateless. Typically, in practice, people sometimes make an exception for authentication, especially in cases where authentication is fairly expensive. You don't necessarily want to do that again with every request. But with that possible exception, generally, certainly it's much easier to implement and more efficient to implement a stateless server to whatever extent you can. All right, so let's go back to our little scene here and figure out, and kind of put REST in context here. So the client sends an HTTP request packet to the server, and it's expecting an HTTP response. So far, so good. So how are we going to arrange that? Typically, your data store doesn't understand HTTP, and even if it did, you wouldn't necessarily, for security reasons, want to expose your entire data store to the web as a whole. So, obvious solution, we put a layer in between. This layer, which we call the Web Data Service or the API, you can call it either, is essentially a translator or an intermediary. It understands HTTP. It knows how to parse HTTP messages and how to send them. And it knows how to talk to the back-end data store. It can do queries to get data. It can do operations to manipulate data. And then it knows how to put together an HTTP response message. All right. So let's focus in on this layer and look at the sorts of tasks it has to carry out. So it's got to be able to parse HTTP requests, separate out the headers, and figure out the parameter values and so forth. It's got to validate the parameters, make sure they all have values within the acceptable range. It's got to know how to talk to the back-end data source. It's got to assemble representations of the data that it gets from the back-end and serialize those representations in one or more formats, such as JSON, XML, Turtle, whatever. It's got to know how to set HTTP response headers properly so that the data is handled in the way intended once it leaves the server. Generate appropriate error messages and provide documentation about itself upon request. So if you look at that set of tasks, I know I'm preaching to the choir here, but if there's a language out there better than Perl at handling this entire suite of tasks, I'd like to know about it. So what makes a good web data service from the point of view of the user? So I'd like to throw that question out to the audience. What would you think? What to you makes a good web data service?
Free.
Okay, free, that's a good one. Reliable, that's a good one. Well documented, excellent. Yes, what else? Well structured, yes.
Predictable paths to the resources.
Predictable paths to the resources, yes. That's a good part of well structured. It's important that if you have a URI, you can look at it and say, okay, this is what this URI is going to give me. Yeah.
Fast.
Fast, absolutely. Responsive. Nothing worse than a slow data service.
Not soap under any condition or circumstance.
Yes, not soap, absolutely. Yes, exactly. Well, that's sort of what the principle number 1 I showed a few slides back. Don't layer anything on top of HTTP. It's a great protocol. It works really well. So, okay. So I kind of summarize this. So well designed, definitely, principle number 1. You want to be able to look at this data service and say, okay, I can see this URL is going to do this. Okay, fine. Well documented, absolutely. Flexible. It'd be nice if the parameters available and the response formats available are flexible enough that you can use the data in a number of different ways and you can get exactly the data you want out of it without having to jump through hoops. Consistent. You want it not to change over time in unexpected ways. In particular, you want that URI to keep working in the future, even if new features are added or the data service defines a new interface, right? This URI, if you posted it on a web page somewhere, should stay functional. And similarly, if you're writing a client application against this data service, you want that application to keep working and not break. And then responsive. So, all right. So I would like to take you through a couple of examples, just 2 out of the numerous data services that are out there. Represents a resource. This is a very common pattern. Just about any data service you will ever use will use this pattern. So you've got some kind of wrapper information that gives general information about the request and the result of it, but the meat of it is an array of hashes. Each one's a resource. Let's see if I can get this. Oops. There we go. All right. So far so good. Oops. There we go. Okay. So let's try it again. Same URL, except we change the format to XML. Same set of resources. An invalid operation. Okay. So far so good. We get a warning. Tells us, or an error really, even though it's labeled warnings. It says, hey, can't understand the request. And if we ask for a JSON format result, we get the same warnings, but as serialized in JSON, which is very nice, because if you're writing a client that's expecting a JSON message back, you want a JSON message whether or not the result is an error. Let's give it a change the operation back and give it a bad parameter, an extra one that it doesn't recognize. Okay, so here we go. We actually get a result, but we get a warning at the top. Hey, you had an unrecognized parameter. So it's a really good idea. Can somebody tell me why? Why is it good, very good to warn about unrecognized parameters?
Because it may be a misspelling.
Bingo. Might be a misspelling of an actual parameter. And if you don't warn the client about that, they may never understand why their request is getting different results than they expected. All right. So one more let's try. Let's give it the base URL only. And we get documentation. It's a good pattern. Not every data service does it, but I highly recommend that. You send back documentation in response to a bare request on the base URL. People expect that often will happen, and so it's a good way for people to get documentation. Also, of course, it's common practice on the web. If you get a URL you don't understand, try chopping off the end components till you get something that comes back. So, note also says this is an auto-generated documentation page. I don't know exactly how they do it, but somehow they are auto-generating based on the set of operations that they are expecting and parameters that they're expecting the documentation page. I'm going to talk more about that later in this talk. But it's a really good idea to set things up so that the set of things that your service is expecting are exactly the same as is documented without you having to physically change the documentation every time. So it lists various operations and the properties and the values that those properties are allowed to, parameters, and the values those parameters are allowed to have. It doesn't, for some reason, list the result fields. Apparently, you have to go to some of these other subsidiary pages for that, but that's okay. All right, so that's the Wikipedia API. Example 2, Google Feed API. So that URL means list all feeds whose title contains Perl, or equivalent, better, more restful way of putting it is return all resources whose title contains Perl. All right, so we'll break this down again. Again, we have a base URL. This is slightly different than the base URL for the Wikipedia case. In the Wikipedia case, the base URL was the entire URL path, and the operation was specified by parameter. Here, the base URL is most of the URL path, and the operation is indicated by the end components. That's the other major pattern here. We do have a query parameter, and we have a protocol version, v1.0. So the Google developers are anticipating that at some point they may want to redesign their protocol and come up with other versions. But by adding a v1.0, this makes sure that URIs written and clients written to version 1.0 will continue to work. All right, there we go. So let's see what we get here. All right, same thing. We get a response message, which has an array of hashes. Each one represents a resource. Note at the bottom here, we actually get the HTTP response status, which is kind of redundant, you would think, because it's actually in the header, except that if you try these URIs with curl, you will find that this data service actually always sets the HTTP response header to 200 regardless, even if the response status in there is something else like 400. Very odd. They also add a header X included response or something like that. Anyway, I don't know why they do it that way. I certainly advocate setting the response status properly. Oh, right, I almost forgot. Also, if you go to the page on the conference wiki for this talk, I set up a page that has all of the links that I'm using so you can follow them along yourself, and also has the slides and PowerPoint on it as well. All right. So, so far so good. So here, let's try a different operation from the same data service. Show the most recent 10 entries from the feed with this URL, perl.com pub. So it's the perl.com Atom feed. So again, same base URL, different operation as the end of the URL path, different parameters. Do we have a protocol version? And this one allows a result set size, which the other operation didn't. Okay, same thing. We get lots and lots of data back, but it's in the same basic arrangement. Let's change a bad value of the parameter. Aha! All right. We get an error message. And note the response status, 400, is the HTTP response status for bad request. It means a request that's malformatted and can't be understood, and thus should not be repeated in the same without modification. Contrast that to 500, server error. That's what you should send back if you have an exception in your code or something other than that's something that's not that does not necessarily indicate that this request is itself malformed. A 500 request can be repeated later, and I'll talk more about that later on in the talk. All right, let's misspell the parameter and see what this service does. Aha, it just gives us the response and ignores the bad parameter. Bad Google. All right, and missing version. All right, invalid version. So it requires that we add a version in there. I highly recommend this. You may be resistant to it because you may figure, well, it's extra parameters in the URL, makes everything. But you know what? Like any software, you may very well decide at some point that the number of design mistakes you made in designing the protocol has gotten to the point where you really need to reorganize it. You know, we all know this happens, right? If you don't demand a version number from the very beginning, you are gambling that this is never going to happen to you. If that's really a bet that you want to make, then be my guest. But making your users specify a version number at the very beginning.
The first version is just undef.
Yes, but then when you change it, then you have to, it's going to cause a lot of confusion. All right, so base URL, we actually get a 404 from that. Bad Google, no documentation on it. You actually have to Google for the documentation. If you care, that's where it is. All right. So what makes a good web data service code base from the point of view of the programmer? We talked about the user's point of view first. So for the programmer's point of view, if you're going to build up a code base or use some kind of framework, what do you want from it? Multiple serializers, absolutely, yes. What else?
A little bit on my resume.
That's a good one too.
Easy to grok API.
Easy to grok API.
Something that's going to be around a while and supported.
Something's going to be around a while and be supported? Yes, absolutely. What else?
Something that describes itself, so some of the work.
Something that subscribes. Yes, very good. Those are all actually very good. Let's see. These aren't quite what I came up with, but those are all good. So easy to implement, easy to document, which means auto-generation of documentation as much as possible. Easy to maintain. So once you've set up or defined a data service, it should be really easy to make changes to it. Low overhead. You want it to get in the way as little as possible with the core business of getting data from the data store and sending it out. And yeah, so let's go back to this list of things that we came up with before. I want to refactor that a little bit. So this is kind of the basic procedure that has to be gone through to handle a request on a data service. Got to parse the URL or URI, whatever you want to call it, to figure out exactly what you're supposed to be doing. So you've got to determine from that information, you've got to determine the operation you're going to be doing and the format that your results should come back in. Got to validate and clean the parameter values. Got to get the data from the back end using the parameter values. So you've got to formulate some kind of queries and talk to the back end about that. Got to serialize the data in the selected format. Set the HTTP response headers appropriately and generate an appropriate error message. Okay, so far so good. What I've discovered over the past year and a half of work is that this is the only part that really needs separately written code for each operation. Everything else, if you configure a set of objects using appropriate attributes and set up a common code base to handle them, everything else can be done through a common framework without having to write custom code. That's the only bit that really needs it. So I have written a module, a framework to actually do this. I call it Web Data Service. It's up on CPAN right now. It's built on top of Dancer, mostly because I started writing my Web Data Service as a Dancer application and ended up doing more and more with my code framework and less with Dancer. But it still handles the basic mechanics of parsing and generating HTTP messages. So basically, you define a set of operations, parameter rules, output blocks, and so forth, and give them appropriate attributes, and it handles the rest for you, including auto-generation of documentation. It is complete enough for real use. It is underlying the live data service for the paleobiology database, which I'll demonstrate at the end. Woefully, I was not able to complete the documentation by this conference, so I'm working on it as fast as I can. I need collaborators and testers and users. My hope is that some of you will be interested enough in it to work with me to really whip this into shape. Partly because I'm realizing I built this to, in order to build the kind of data service I would build. And I need to work with some other people who would build things differently to make sure it's flexible enough to suit everybody's needs. So if you're interested, come and talk to me, please. But I want to make this a useful talk to you whether or not you decide to use my particular module. So let's talk some general principles. If you're going to build a data service, here are some early decisions that you need to make. You need to decide which framework to use. That's important. You need to decide how you're going to validate the parameter values. That's going to influence a lot of how you structure things. And how you organize the parameter space. You're going to have to decide how to handle output formats, how to implement the response procedure, how to handle versioning of your protocol. I talked about that just a little while ago, and how to report errors. So those are things that it's really important to think about from the very beginning. Oh, and how to handle documentation. Yeah. Decisions that can wait. Which HTTP server you use is not so important because whatever framework you use can probably work with any HTTP server that you want, and you can switch from one to the other. So don't really even think about that too much. Talking to the back end. That's pretty arbitrary too. You can do it however you want. In fact, you could even decide to switch your back-end data store halfway through or after you've already implemented it. And if that's more work for you, but if you do it right, the users will never notice because the protocol they see stays the same, right? The important thing is to fix the parts that are going to be visible to the users so that you can have a consistent interface. Similarly, right, avoid premature optimization. Caching and performance improvements can wait until you got the basic thing working. So those are things you don't have to worry about from the very beginning. Plan for these from the start. List of things. Multiple output formats. If you plan from the start that you are going to allow any of your output responses to be serialized in more than one format, then when your users come to you and say, great, love your data service, can you send me the data in XML? You're prepared. Similarly, multiple output vocabularies. Hey, I love your data service. Can you match this standard vocabulary that my particular industry or group uses? You're prepared. Multiple protocol versions. Already talked about that. If you're not, unless you want to gamble that it's not going to happen, be prepared. Auto-generated documentation. If you plan to auto-generate your documentation from the very beginning, then it's more work at the start, but way less work later because any modifications you make to your data service get automatically reflected in the documentation without you having to add an extra workflow step. So let's go back and deal with those decisions one at a time. So these are the frameworks that I would recommend. This is just based on my limited experience. These will all work. Dancer 1 is what I built my service on top of. It works great. If you prefer the more object-oriented approach of Dancer 2, that would work well too. I don't have any experience with Modulicious, but from looking over the documentation, it looks like it would work just fine. And then, of course, my own web data service. Parameter values. So you need some strategy for validating and cleaning the parameter values. Basically, pretty much needs to be, if your data service is at all extensive, if you have a lot of different operations and parameters, you're going to want a rule-based approach where for each parameter you can just specify here are the rules it has to follow and here are the errors that should be returned to the client if the parameter value falls outside of what the rules accept. I've actually written a module to do this. It's called HTTP Validate. It's in much better state than Web Data Service. In fact, it is well documented and ready to use. It is a standalone module and can work with any web framework, and I highly recommend it. So check it out on CPAN. Basically allows you to define allows you to define rule sets which apply rules to various parameter values and can accept or reject parameters of different types, numbers, strings, enumerated lists, etc. You can call one rule set from within another so that you can define rule sets for particular groups of parameters and then mix and match them to make rule sets for particular operations. And it includes auto-generation capability. So, and I put in an example. So here we go. We define rule set, give it a name. Here is a specification for a particular parameter. Says how are we going to tell which are the valid values, etc. And then we follow it by a list of documentation strings. These are collected up and used to generate documentation in pod format, which you can then translate to HTML or whatever you like about the rule set. And this is done recursively. So again, if you define rule sets that include bits and pieces or include other rule sets to form the entire rule set for an operation, it'll generate exactly what parameters that operation takes. All right, decision 3, parameter space. How will users specify which operation to do? There are basically 2 schemes that I've seen used. One is the end of the URL path, and the other is a parameter. Both work. You just have to decide which one you want to do. Output formats. Similarly, how will users specify the output format? You can specify it as the suffix on the URL path or as a separate parameter. Again, both of these work. You just have to decide which one you prefer. My recommendation, however you do it, is to separate the definition of output fields from output formats. So, as you mentioned, having multiple serializers, you need an abstract definition of here's what the output fields my service is going to produce, and the serializer should be able to take that and munge that into a JSON format output, an XML format output, a turtle format output, text format output, HTML format output, whatever selected. In fact, Web Data Service does that. Allows you to define output blocks, which list fields, gives the attributes for every field. Again, we've got a set. You can put documentation strings, and these are collected up and used to form auto-generated pod documentation. So you can put together the parameter documentation and the field documentation and produce a documentation page that lists exactly what your clients need to know for any particular operation, what parameters to send and what they're going to get back. And then again, Web Data Service provides plugins for JSON, XML, and various text formats. And you can add your own. So you can define as many output formats as you like. You just have to write the plugin module to follow a very simple interface. And it will be able to generate any output in the particularly selected format. So, procedure. Again, how will you handle the basic request response procedure? So, my recommendation, again, whether you use my framework or not, is that you specify a set of attributes for each operation and use a single body of code to handle operation execution. If you're building your own data service from scratch or using a general web application framework like Dancer or Modulicious or Catalyst, you will probably find yourself tending in that direction anyway, I'm guessing, because I certainly did. So this is how Web Data Service does it. You define nodes for each operation path. You give it attributes that say, okay, this is how a request using this path is going to be handled. And these things are hierarchical. So the node for taxa, those attributes are inherited by taxa single and taxa list. This is fragment of the code for the paleobiology database data service, the part that lets you retrieve lists of taxonomic names. So you define, basically using Web Data Service, what you do is you write classes for each different kind of data you want to return, and then methods that are associated with the different operations. So this is basically all that I, wearing my data service author hat as opposed to my framework author hat, have to write are the particular methods for fetching the data and handing it back off to the framework, which then uses the set of output fields that are defined for that operation to assemble the data properly, and then the selected serializer module to properly serialize it, and it all happens magically. It's great. How are we doing? Oh, good. Good on time. So, decision 6, versioning. Again, there are two different ways, basically, to specify the protocol version. You can add a v equals parameter, or you can stick it in the base URL. I actually favor the second one, although for some reason most people seem to favor the other one. But however you do it, it doesn't matter. The point is that it's clear exactly which protocol version every URI applies to. There's no ambiguity. Error reporting. My recommendation is report errors in JSON if that format was selected. We saw that with the Wikipedia API. Otherwise, you can send them back in text because it really doesn't matter for anything else. My recommendation is use the HTTP result codes for their intended purpose. These will cover about 99.9% of all cases. And then my recommendation is if your code throws an exception, report a generic message. Error occurred, or maybe error number 217B occurred. Contact the system administrator, please. In fact, let me amplify that. I've used data services that throw back a whole stack trace. Not useful. Your clients do not want a stack trace from your code. They just want to know, hey, this is not my fault, it's their fault, so I need to send in a bug report.
Actually, why wouldn't you give them at least some information to help them diagnose the problem?
Well, because you may, for security reasons, not want to export the details of your code is one reason. It depends on, I would say, okay, it depends to a great extent on what your security considerations are. If this is a totally open system and you really don't care if people are going to hack on it and play around with it, then sure, if you really want to. But in many cases, you really don't want to do that. And there's something to be said for publishing a really complete documentation of your interface and saying, here, my guarantee to you is if you follow this protocol here and give the proper parameter values, here's what you're going to get back. And if it doesn't happen, it's a bug, so tell me.
One of the things that I found really useful as a client of some services is there's one in particular I've worked with where I can send a UUID.
Mm-hmm.
So I generate a UUID for my logging, and I send that to them, and that goes into their logs. So when there's an error, I can contact them and say, okay, in my logs, this is what I saw, here's a UUID. They can go find it in their logs.
That's a good idea.
And that's fantastic.
Yeah, that is a very good idea. Of course, server logs generally do log the requester IP address and agent code and so forth, and you can use that too.
Trivially trackable.
Yes, exactly. So yes, you can always go through your logs and find. Yep.
Well, I was just going to say, we've had that kind of issue because our Windows network is DHCP saying, oh, 3 days ago, this IP address, that's not necessarily corresponds to the same machine.
That's true. User agent string can help there too.
Well, they're a company machine, so they're all running.
Oh, okay, got it. Then you're right. A UUID is probably not a bad idea there then. Yes, that is a great idea.
As far as error codes, the HTTP error codes are concerned, one distinction to make is that the 400 class of the error codes, 400, 404, 415, are all things that are quote unquote the client's fault.
Yes.
And then like a server error, if you have an exception that's something that is the server's fault, throw in a 500.
Yeah, exactly. Yes. It is important to understand that, so that yes, all the 400s are basically, this is a bad request, don't repeat it. 500 is, the request didn't succeed, but it wasn't because it was a bad request. You can try again later. So that is a very important distinction to make, yes. And 415 is what I send back if the client requests a format that I don't support. So if they request XML and my service doesn't support XML, I send back a 415. That's the closest HTTP error they have to that. So documentation, again, as I've said before, I recommend that you auto-generate your documentation as much as possible. For a complicated web service with lots of operations and parameters, it's the best way to make sure that what the users think they can do and what they can actually do are in accord. And again, I suggest that a request using the base URL with no parameters should return the main documentation page with links to all the subsidiary pages, so that using that as an entry point, the users can get to all of the documentation necessary to successfully use your service. And so going back, yes, I recommend that if you were going to write a web data service using the HTTP protocol, you should know that protocol backwards and forwards. You should know the status codes. You should understand the CORS system. You should understand cache control, what you can specify for the cache control header and when you should do that. You should understand the content type system and the disposition section for that. It's really nice to be able to control whether when the user makes a request, whether that's directed to be saved to disk or displayed in the browser window. So those are all things that are part of the HTTP protocol. They're well documented by the W3C. You just have to go out there and read them. All right, so I got about 3 minutes left. Just want to give you a really quick demonstration of what I built using these ideas. So this is the Paleobiology Database Navigator. We are the largest collection of information about fossils in the world. We're used by the world paleontology community. We have about 400 active users and contributors.
Can we go back and see this?
Sure. There we go. That one's not in our database. I'm not quite sure why. Okay. Let's see. Yeah, that one is. There we go. Okay, there we go. So here we go. So here is where all the T-Rexes, at least that are in our database in the world. We don't have all of the fossil record entered, but we're working on it as fast as we can. And so you can see where things have been. You can see what else was found with them. Let's actually go back.
What's the rendering technology?
The rendering technology is D3 and leaflet. There we go. So here we go. Tyrannosaurus rex. That's all that was found there. So anyway, there's lots of stuff you can do with this. You can say, okay, well, so I'm interested in all the Triassic fossils in the world. Where have they been found? Or the Permian ones. Here we go. So you can, and then you can filter them by, what kind of thing, when, where, etc. And then you can download these lists in various formats, including comma-separated text, which you can then load in a spreadsheet and do analysis with, which is what our paleontologist users want to do. Or you can get it in JSON. This web application, I didn't write this. This was my colleague's work, but it uses the data service that I created. So here's what the data service looks like. Oops, look here. Okay. Let's go back to here then. Okay. My machine freeze. It may have. Okay. Well, let's try force quitting PowerPoint and see if that works. Okay. There we go. Okay, so let's go back to the data service. Oh, I bet it. Network, yeah. All right. Yes. Oh, man. Well, I may not get to the demonstration of showing my data service, but hey, it's okay. Let's see. Do I have any more slides on here? What do I got? Oh, yeah, there we go. Okay. So, please let me know if you're interested in using testing or helping me further develop this module. Especially if you're interested in using it once I get the documentation cleaned up. Let me know now. That'll give me some incentive to really work fast on this. So that's my email address, mmcclenn@geology.wisc.edu or at CPAN, either way. And let's give it another try and see if it's got, yeah, there we go, okay.
Hello.
Let's see if we got, in the 1 minute we've got left.
Sort of.
So any questions while we're at it? Yes?
One thing that is very common that you need to do in APIs that you didn't really touch on is authorization for use of APIs. How do you handle that or recommend?
Ah, yes. Okay, very good one. The answer is ours is read-only so far. I haven't gotten to building that one up yet. So it's a really good question, and I don't know what the best answer is to that. You know, as I said before, authentication is typically the one exception in practical terms made to the stateless principle of REST. I mean, if for no other reason than that setting up an HTTPS connection, for example, is by definition not stateless. Once you set it up, you have that state, you know, between you and the client. So typically, I mean, there are pretty much, you know, only two ways to do it that I know of. You either send the user a cookie that then you know, gets included with each subsequent request, and you can use to authenticate them. Certainly, if you do that, you should definitely make your data service work over HTTPS rather than HTTP, because otherwise anybody could snoop the connection and grab the cookie and get that, you know, and put in requests that look as if they're authenticated properly. And the other way is to send back some explicit authentication token that they need to include as a parameter. But either way, yeah, I mean, they have to have some kind of token.
And it's also a good idea to do like an ACL if they know, if you know
Okay.
what pages they're going to be coming from.
Oh, there we go. Okay, there we go, finally, okay. So here's the main documentation page for my service. We've got lots of different things you can get. So you can get, for example, single occurrence. I've got examples to show people how to use this. I've got, let's see, let's pull up a list of occurrences. It's normally not this slow. I can tell you this is the hotel network, not my server. Well, actually, as we could tell, because before, when the navigator was running, it was making a whole bunch of API requests. Every time the set of dots was updating, that was another API request. And those were working just fine. So I think it may have forgotten that I'm authenticated again. But at any rate, so this is the kind of auto-generated documentation you can get. Let's see if it'll at least pull up that. Oh, man. All right, well, check it out, paleobiodb.org/data 1.1. Aside from the descriptions at the top, the documentation pages are all auto-generated. So the lists of parameters and values and output fields are all derived from the ones that I've configured with the documentation strings that were right there with each configuration record. So when I change the configuration on a parameter, all I have to do is change the string right there. Boom, got a whole list. So thank you very much.